Now we're going to briefly consider composition of functions numerically and graphically. Here we have three functions evaluated for specific values of x given in the table. So we have our table here, x and the values that we evaluated on the far left column, and then each of the different functions and their y values corresponding to the specific x. So, for example, we would say that f of negative 2 is 0 because f of negative 2 gives me 0, right? So reading that table as it is. We can put some double lines here for the x, maybe make this one a little bit bolder for the headers. So this first column is x values, and each one of these last three columns are all y values for the three different functions. Okay, so an example of using the table, we can see that f of 0 is 2. So f of 0 is 2 because it's in the f column and the x is 0. And g of negative 2 is 7. So we can use the information in the table as just like a table of values if we were graphing a function. We just have three functions that we're working with. Now these questions are asking us to evaluate each expression using the table of values. So let's start out pretty simple. H of negative 1. X is negative 1, so we'll find negative 1 in our table. And we follow that over to H, and we see that H of negative 1 would give us 1. When we're doing compositions, the difference is that instead of just doing that one value, now we're going to do it twice, and we're going to use our old result to get the new result. So I'm using the answer that I got from the inside to put it into the new function. So my new x is 1. Use a different color. My new x is 1. And now if I go over to g, I see that g of 1 is 1. So I've gone through that composition of a sequence of steps. Let's try the next one. G of f of negative 2. So we start out with negative 2 for x. We locate f at negative 2, and we get 0. So f of negative 2 is 0. So I'll put that 0 in there. And then g of 0, now I find 0 for x, and g of 0 is 3. And then we can look at f of 0. Clean up my table a little bit. F of 0, x is 0. We look at f of 0, which is 2. So f of 0 is 2. And now the 2 is my x value that I'm now plugging into f, and I get 4. We use the inside function first to get a result. That y value that we get from the inside function becomes our new x value that we put in for the second outside function. It's a two-step process. Keep practicing with this. Another example to practice right here on the next page. A few more examples to take a look at. I'd like for you to pause the video and try this one on your own. And when you think you've got it, resume and I'll walk you through the answers. In the new problem, we look at h of negative 2. So negative 2 is x. We follow that over until we get to h, and we see that h of negative 2 is 0. In number 6, if we write this in parentheses notation, you may notice that h of 2 is right there, and we just found h of 2 in the previous problem. So we'll get g of 0. Notice the previous y value is now my new x value. So x value is 0. Following it across to g, I see that g of 0 is 1. And then the last example, f of 3. 3 here is my x value. I see that f of 3 would be negative 2. So f of 3 is negative 2. And negative 2 becomes my new x value, which I'm going to mark over in orange. So negative 2 is my new x value, and I'm going to plug it back into f again, and I see that f of negative 2 would give me 5. And I know that might be difficult to see since it's at the very bottom. That would be performing compositions numerically using tables. In the next part of our lesson, we'll look at using graphs for compositions.